you. Just a quick overview of what I'm going to talk about today. I appreciate your guys' time today. My main goal out of this is to, I hope, give you guys some ideas of what areas are important to at least me in the industry, and I think the industry in general as far as wireless sensor networks are concerned in the industrial space. So I'm just going to give you, I know many of you have background in wireless sensor networks, but I want to give you a brief overview of what it looks like in the industrial space, a little bit of overview of what we're trying to get to in the control space with wireless sensor networks. There's also the aspect of safety systems in the industrial process automation world. That's another place where our customers are asking us to bring wireless technology because a lot of times you want safety instruments in places where you can't run wires too easily. So the customers are pulling this from us, and we're looking for some help there. And I think there's some other research opportunities beyond that I'll throw out just as some extra credit, if you will. So just at a high level, very simply, wireless sensor networks, we've been doing it in the industrial space in process automation now for about 6 years, really in the field. We've got lots of time with these systems in really ugly environments. I mean, these places, you probably, some of you saw some of them as you're driving in from the airport. There's big tanks, there's cable trays, there's piping, really difficult environments from an RF perspective. But yet, the technology lends itself to working in those environments for a lot of different reasons. Lots of networks, lots of instruments, well proven to be robust and reliable in these environments. The other thing, they exist all over the world. It's not just in a nice factory somewhere where the temperature is 75 degrees Fahrenheit every day. We've got networks that operate in Siberia, minus 55 degrees C, North Slope of Alaska, very near that, the deserts of Oman and Saudi Arabia, where it gets to be, at least inside the instrument, the electronics, where we live, our software lives, it's very close to 85 degrees C inside those enclosures. And so we run the gamut of what the world sees out there. Offshore, lots of nasty environments out there. The North Sea off the coast of Norway. Every place in the world. And if you're interested, you just do a search on Emerson and Extreme Wireless. There's a video out there that shows you some of the examples that might be interesting to you and see the environments that we really live in. So just a brief overview on what we do in the industrial space. I know this is a bit of sacrilege here. A lot of people don't like to talk about centralized network management, distributed network management. That's a lot nicer problem to deal with. It's more scalable. But for us, centralized network management gives us the ability to do real-time systems the way we need to in process automation. Without it, we can't guarantee deadlines for control applications, for safety, even for general monitoring. It would be really difficult. Once you start pushing beyond 8-second update rates, maybe down to 1-second update rates with real measurements, you got real deadlines that you have to deal with. If you're talking about hundreds of devices all trying to report at 1-second rates, it's a real problem. So centralized network management actually gives us an advantage there. Mesh networking, what does that do for us? I got an indication from my colleague, Dr. Liu here, that people were in the panel earlier today. Mesh networking is dead. There's no interesting stuff to do there. Okay, well, I'm here to tell you I don't think that's the case, but hopefully you'll agree with me by the time I'm done here. Very important to us because of the redundancy aspects we get. Without it, the reliability and robustness of these networks goes down exponentially. We have to have it. These environments that we live in, very, very difficult. Most of the networks today, I don't know what the percentage is off the top of my head, but most of them today are dealing with publish-subscribe models, mostly publishing. The device is just, here's my process data, system, do with it whatever you want. But the more difficult problems we'll talk about later with control and safety. Cybersecurity is a key. These facilities, multi-billion-dollar facilities that these instruments go into, if bad things happen, significant problems to both your neighborhood, somebody else's neighborhood, the environment. So being able to protect these instruments and the systems that they interact with, very important. This last one, I can't emphasize enough. Most of these devices, 99% of them that we have deployed around the world, run on batteries. We don't get to plug into the wall. I would love to be able to run an FPGA like some of my colleagues suggested earlier. I'd love to be able to do that. I can't. I've got to run on batteries for 5 to 10 years. That's what our customers are asking us to do. So we need not only, it's a multi-parameter optimization problem, as you can probably start seeing here. But in today's systems, most of the data flows towards the controller, towards the host system. So let's look a little bit at the control case. This is one of the places that we're looking for some help. There's been some good research done by Dr. Liu and Dr. Mock here at the University of Texas. But I just want to concentrate a little bit on this piece of the network down here where the control is happening. There's many different kinds of communication in this case, both peer-to-peer. There's set point changes that are happening coming from the SCADA or process automation system. But there's also publishing going upstream from the devices to let the system know here's what the actual status of the system is. So you have many different kinds of data flows that you need to optimize the routing algorithms for. Plus, again, we need to worry about battery life. We need to worry about battery life of the network as a whole, not just one device, but all the intervening devices. We need to continue to provide redundancy. We need to meet the control deadlines. All this has to happen in parallel with the stuff I just talked about, the standard publishing model that the devices are doing out there. So we've got to be able to do control mixed with the everyday operation of these networks. Not a simple problem. Safety, another application that we would really like to expand in the wireless sensor network. This is a different case in that most of the safety protocols today, as defined by international standards, tend to be client-server. In order to ensure that the safety system is in the state that the system believes it's in, a request goes out, it asks that sensing device, is everything okay? Like in a hazardous gas situation, do you detect H2S, for example, or other types of gases that would be hazardous to the people that are on the plant? It's got to respond back with certain aspects in that protocol to let the system know, yeah, everything's fine. So the system knows that device is there, it's doing its job. So again, being able to mix that type of interaction, client-server, with the publishing model that we're doing, and again, potentially with control, all in the same network, multiple optimization parameters we've got to worry about. And again, we've got to save battery life. Again, not a simple problem. So, that's the basics. I think the research opportunities, in my opinion, are great. There's been a lot of good work done already, but there's a lot more, in my opinion. We can do better, we can do more. Just at a high level, though, we've got to be able to continue to do what we're doing today. Devices publishing up to the system. I'm measuring pressure, that's important to the system. I'm measuring temperature. We've got to bring these hazardous gas detection devices in with the safety application, client server. We've got to be able to save battery life, just like in all the devices across the entire network, not just on a localized matter. We've got to keep the redundancy, and we'd also like to run some control stuff mixed in there with that. So one of the key components of that, so lots of complexity there, right? The piece of hardware that network manager is running in doesn't get to run at 3 gigahertz either. It doesn't have 8 cores. I wish it did, We've got to be able to run this device, again, in hazardous locations in some cases. So we can't run ultimate power. We can't be running off a 100-watt power supply. We get to run off of like 5 watts. You can't just solve the problem by throwing a whole bunch of CPU power at it. We need algorithms that can run in small amounts of time on limited hardware. The resources aren't unlimited in these cases. Embedded systems are running these algorithms. So again, another parameter that you've got to optimize around. A few others. So network management, I think there's lots of fun stuff to do there. Hopefully some of you will take notes and come talk to me later. Some other things though, location tracking. In our world, safety of the people and assets in these plants is paramount. I've talked to several customers just in the last few months. The first thing they say to me is, how can you help me keep my people safe? If we can track those people well, we know exactly where they are when an incident occurs. If we can even go to the length of helping them get out of a hazardous area without getting towards the hazard, whatever that is, because they don't necessarily know where it is, but help them navigate out of a hazardous area and be safe, that would be huge. This is not a simple problem. Lots of people have done research on it again. We're getting closer all the time, but the more we have, the better we'll get. And since we're talking about cyber physical systems, security is always paramount. Our customers, when we first started talking to them, they said, what do you guys know about security? How are you securing my networks? How are you going to secure my data? So security today is mostly symmetric key. You may have seen that earlier. More difficult from a user's perspective is PKI. Is that the solution going forward? Maybe, but again, we have to remember that we have limited horsepower, limited resources in these devices. There's been some research done on ECC. Maybe that's the thing. I'm also looking for, what else do you guys have? I mean, what else can we run on a small 32-bit ARM processor that its primary objective is not security, it's measuring things, right, and getting that data up to the system. So we need something that runs in a very limited horsepower, but yet is extremely strong from the customer's perspective and has been vetted, for years at a time, much like AES has. So I think there's lots of interesting problems in this space yet. So hopefully, if you heard that mesh is dead, it's not. There's lots of good stuff to do. And I'd love to talk to you about more opportunities afterwards. Thank you.
Time for some quick questions.
Thank you for a very interesting talk. A lot of challenges for us and problems to work on. One thing you said very early, it sounded like a direct challenge to the community, was that it couldn't be done, this distributed network management, because of the timing constraints. That sounds like things that we should be looking at. Is it that it can't be done because we don't know how to do it, or there are other reasons it shouldn't be done? That it's from a business perspective or management issue?
Excellent question. What we've seen so far, I guess I'll put it that way, maybe be a little bit more accurate, is that distributed network management routing protocols have not met our needs in the industry. I'd love to see cases where that's not the case, because one of the things we run into with centralized management is, as you all know, it's the scalability. I mean, that's the thing we run into. Now, there's ways to get around that, but you start putting bigger and bigger network management hardware in place to make that happen, right? And so if we can get to the point where we've got algorithms that can be distributed and we can meet our real-time deadlines, I'd love to see that. But up to this point, we haven't been able to see everything. All those challenges we haven't been able to meet.
So this brings in an interesting point that I think that it would be great if you would say, oh, here is one of the problems that we're working on that we don't some problem sets that were published in the real-time community, and that kind of fueled a lot of the research. And that would be interesting to say, you think it cannot be done, but I already have a solution. Or you think it cannot be done, I agree with you, right? So,
Sure, yeah. Great point. One thing that I failed to talk about earlier is that every one of these systems has their own unique attributes in the field. So one of the things around optimizing each of these parameters is, at some level, we need to give our customers the knobs to turn depending on what the actual system is, right? Now, one of the things that I'm challenged with as a product developer is my managers come to me and say, our customers don't know how to turn those knobs, what the settings should be. You need to figure out, based on the information you have about these devices, about the network topology, so on and so forth, you put those settings in there automatically. So there's that challenge as well. So my point being is that putting together a problem statement, yes, I can do that. The difficulty is, one problem only solves one customer's problem. It's not a broad problem necessarily, but it's a good challenge for us to do.
We'll take the questions after the break.
Okay.
After